In previous classes, we discussed about these force and laws of motion. So, chapter is completed and we have done some problems also in it. Now, to continue the next problems, then after that, we can continue the next chapter. Okay. So, now some problems will be remain in this chapter that we have to continue in this class. So, next problem. So, I will take your question number. Now, here. What force is required to produce an acceleration of 3 meter per second square in an object of mass 0.7 kilogram? So, what force is required? What is the question here? What force is required? What force is required to produce an acceleration of an acceleration of 3 meter per second square, 3 meter per second square, if an object of mass, 0.7 kilogram. So mass of the object will be 0.7 kilogram will be given and acceleration will be given as 3 meter per second square. Then you have to calculate the force acts on them. What application you have applied here? Force is equal to mass into acceleration. So F is equal to ma. What is the mass of the object? Mass of an object. Mass of an object m is equal to 0.7 kilogram and acceleration a is equal to 3 meter per second square. Then force acts on the object. Force acts F is equal to how much? So F is equal to ma. That is 0.7 into 3. So 0.7 into 3 means 21. Point will be there, 2.1 Newton. So force acts on that object will be 2.1 Newton. Therefore, force acts on the object will be 2.1 Newton to be considered. And another problem to be considered. Next question to be considered. A force acts for 0.2 seconds on an object having mass 1.4 kilogram initially at rest. The force stops to act, but the object moves through 4 meters in the next 2 seconds. Find the magnitude of the force. So here we have calculate the magnitude of the force you can be applied here. Now in this application I have to consider what is the given thing. A body is at rest. So at rest means its initial velocity will be 0. Mass of the object will be given as 1.4 will be given and time will be given as 0.2 seconds. The distance covered by body after force stops will be 4 meters. Then time taken to stop the distance will be 2 seconds. Then final velocity of the body you have to calculate. That is v value you have to calculate. All these values you have to substitute. So first of all to see the question. A force acts for 0.2 seconds. For 0.2 seconds on an object having mass 1.4 kilogram initially at rest. Now the force stops the force stops to act. Force stops to act, but the object moves. But the object moves. But the object moves through 4 meters. Through 4 meters. 4 meters next to 2 seconds. Next to 2 seconds. Find the magnitude of the force. Find the magnitude. Find the magnitude of the force. That's the question. So in this question, what happens? Mass will be given. Body starts from rest. Rest will be 0. U is equal to 0 will be given. And distance covered is given as, after applying the force, distance covered by the body will be 4 meters. And time taken to stop that body, time will be given as 2 seconds. By using that, we can calculate the final velocity. V is equal to S by T application is there now. To calculate V is equal to F by T. Then we can apply this formula. All that values to apply in the formula. F is equal to M into V minus U by T. Then you get force acts on the body. Understand? In this case, U will be given as 0. V value I have to calculate. For calculating that, distance and time will be given. By using that, you calculate V value. Then mass will be given. After that, you substitute all these values in this application, you get F value. Okay? So, an object starts from rest. So initial velocity U is equal to 0. Initial velocity U is equal to 0. Now the distance covered by an object after the force stops is equal to the distance covered by the object after force stops, after the force stops. S is equal to 4 meters. Time taken T is equal to 2 seconds. Then velocity of an object V is equal to how much? Velocity of an object V is equal to how much? V is equal to S by T. You know that application. So from that you can apply these values. So V is equal to S by T, that is equal to S is 4 meters, time is 2, 2 ones are 2 twos are, that is equal to 2 meters per second. Final velocity V is equal to 2 meters per second. Then here, time taken by the body to cover the distance will be given as, T value will be given as 0.2 seconds and mass of the body given as how much? 1.4 kilograms. 1.4 kilograms. So this kilogram meters per second will be there, no? 4. SI unit will be considered 4 kilograms. Then force acts F is equal to how much? F is equal to M into V minus U by T. That is equal to 1.4 into 2 minus 0 by 0.2. That is equal to 1.4 to write as 14 by 10. No? 1 point will be there. No, adjust that to write like this fraction 4 by 10. This is here 2. 2 minus 0 means 2 by 0.2 means it is also to write as 2 by 10. 2 by 10. Now, what do you get? That is equal to 14 by 10 into this 10 goes up. So 10 into 2 by 2. 2 gets cancelled, 10 gets cancelled. Then what's remain? 14 14 Newtons. So in these cases, if velocities are directly given, to apply the formula. Here distance and time will be given. So you can calculate the final velocity by this manner. And initial velocity starting from dust will be given, no, you will be taken as 0. Okay. Now all of these values substitute in this application. We get, that is V minus U by T into M. We get the force acts on that body. Okay. Now another question we have to see. Another question. Another question to be considered. Same formula here apply, but method will be different. An object of mass 5 kg is moving with a velocity of 10 meter per second. A force is applied so that in 20 seconds it attains a velocity of 25 meter per second. What is the force applied on the object? So same application, but all the values were given directly. Then we can apply in this formula. Okay. So here an object of mass. First question to say, an object of mass 5 kilogram. An object of mass 5 kilogram is moving with a velocity of 10 meters per second. 10 meters per second. A force is applied. A force is applied so that in 20 seconds it attains. In 20 seconds it attains a velocity of 25 meters per second. 25 meters per second. Now, what is the force applied on the object? What is the force applied on the object? What is the force applied on the object? Let's say application. F is equal to M into V minus U by T. Same application you had a previous problem. What application you had done? Same application to that, but here directly initial velocities and final velocities of an object is given. So that's why that values are substituted in this formula to get the answer. Okay. So application to write first. F is equal to MA. In this mass of object. Mass of an object. Mass of an object. M is equal to 5 kilograms, 5 kg. Initial velocity. Initial velocity of an object. U is equal to 10 meters per second. 10 meters per second. Final velocity. Final velocity V is equal to 25 meters per second. 25 meters per second. Time taken T is equal to 20 seconds. 20 seconds time will be given. Then force F is equal to how much? So all the values to apply in this formula. F is equal to force F, capital F is equal to M into V minus U by T. Now that is equal to 5 into V, 25 minus U, 10 by T, 20. 25, initial velocity 10, mass 5, time taken 20. Now that is equal to 5 into 25 minus 10 means 15. 15 by 20. Now 5 ones are 5 fours are. Now there is no cancellation. To divide this 15 with 4. What do you get? 15 by 4. So that is equal to 3s are 4 3s are 12, 13. So to keep point 0. So 7s are 28. So already point will be there 5. So 3.75 Newton's force will be acts. So F is equal to 3.75 newtons. That's all. Okay.